Hi, and today I will talk about one more example of the polymers, polypropylene. And of course, from its name, it comes by polymerization of propylene. The shortcut is PP, and of course, you have seen that on different plastic because this is the second most common plastics. Its are similar to those of polyethylene. But polypropylene is harder and it has a higher heat resistance. It also has a higher chemical resistance. It is tough and flexible. Polypropylene is tough and flexible, and it is a thermoplastic polymer. If you remember, thermoplastic polymers is the type of polymer that melt by heat when the temperature is raised. It is the polymer is melted, and when it is lower down, when it is cooled down again, the polymer is solidify again without any change in the chemical properties. Polypropylene has three types, and this classification depends on how the methyl group is distributed on the polymer. There are three types of polypropylene: atactic, isotactic, and syntactic. The atactic polypropylene, as you can see down here, the methyl group is randomly distributed. There is no regular pattern of distributing the methyl group on the polymer. And the distribution of that methyl group provide different physical properties to the polymer. This polymer, this polypropylene, is amorphous in structure, in texture, and there is no crystalline formation, no crystal structure, and it has a low density and melting point than the crystalline type. So in polypropylene, we have a type which can crystalline and another type which can't crystalline. Like the atactic propylene, it's amorphous and couldn't crystallize. There is no crystal structure. So this type has lower density and melting point than the crystalline types, and rubber-like at room temperature. This makes it better to be used as an insulating material. Isotactic, we can see here a regular distribution of the methyl group, and they are in the same direction, the polymers, which give the polypropylene, excellent properties such as low density and high thermal stability and good solvent resistant. Plastic, and it is widely used commercially. The syntactic polypropylene, or SPP, here we have a regular distribution of the methyl group, but there is an alternative alignment. So one methyl group in a direction and the next to it will be to the opposite direction, and so on. So as you can see here, there is an alternative distribution of the methyl group, regular distribution, one up, one down. This type of polypropylene is highly crystalline, so it's solid, it's hard in its shape. It has a lower melting point than isotactic polypropylene. All of these are several examples of using polypropylene in manufacture. It is really widely used in the normal stuff around us. And to wrap up what we have said today, polypropylene is the second most famous plastic after polyethylene. It differs slightly in the physical properties than polyethylene, and it is also classified into three forms, which the classification depend on the distribution of the methyl group on the polymer. We have atactic, isotactic, and syntactic. Atactic, a there is no normal distribution, there is no regular distribution of the methyl group. The isotactic, there is a normal, isotactic and syntactic have normal distribution, but isotactic has all the methyl groups on to in the same direction of the polymers, while syntactic have an alternative regular distribution of the methyl group, one up, one down. Everyone has its own properties and its own usage, which make it better than the other in a certain purpose. Thank you, guys.